Okay, let's do the second part of this question. What is the RMS speed of the iodine molecule at 200 degrees C? Okay, so in order to do this, what we know essentially is that the molecules are moving around in 3 dimensions. They're, if we had an X, Y, and Z system, we know that the heat capacity, this thing right here, is as a result of this molecule moving like this in all these different directions. And so to derive an equation, you'd have to you actually relate this heat capacity to the fact that it's kinetic energy. It's 1/2 mv squared. But the v now is in the x, y, and z direction. So to derive this equation, you can kind of relate that to CV and go ahead and derive it, making sure you took care of all 3 different dimensions. But I just want to show you a place on the equation sheet. Let's see, where is that equation sheet? Where some of this information is captured. So this is Pete's equation sheet. And you could see, okay, so here's the formula sheet. The formulas that involve pressure are over in this area, right over here. And you can see that this equation right here shows you the relationship between pressure, volume, the number of molecules, and the VRMS, which is what we're looking for. So we're looking at using this equation. So the real tricky part here is going to be the units. So let's reproduce this equation. Another spot here. I'm going to move this over. Okay, so I need a blank sheet here, so I'm going to give myself something to work on. And we know here's an equation. I like this pen. We know that pressure is 1/3 N over V times M VRMS squared. Now, the units are a little dicey here, but this N, it turns out, is the number of molecules, and M is the mass per molecule. And I want to point out that pressure times volume is nRT. We know this also from the equation sheet, or the famous PV equals nRT. N is the number of moles. R is usually expressed in joules per mole Kelvin. So that makes, if we rearrange this, so if we say PV equals 1/3 NMVRMS squared, we can set these equal to this PV and RT. So we know the number of moles. We know this is 2. We know what R is. We know the temperature is 200 degrees C. But remember, in these formulas, T is almost always absolute temperature. So 2 plus 273 to get 473 Kelvin. We're looking for the RMS speed. And what about these 2 values? Well, right now, they are, or in the equation, normally they're molecules, mass per molecule, but we could actually use moles and multiply it times mass per mole to get the same relationship. Or we convert the number of moles to the number of molecules by saying, moles equals, let's see, the number of molecules. Ooh, I see the confusion here. Molecules times Avogadro's number. Mass per mole, we would actually divide it by Avogadro's number to get mass per molecule. So you can see that they cancel out. So let's use, in this case, so I'm sorry, maybe you can't see that. Let me show you. NM is equal to the N number of moles times Avogadro's number. That equals the N. Let me just erase this. And okay, so that's N. Mass per molecule is actually, if we it's the same thing as molecular weight divided by N sub A. So you can see that in this case, the n sub a's would cancel. So we can say n times n, the mass per molecule times the mass per, the number of molecules times the mass per molecule is the same thing as the number of moles times the molecular weight. And these are the values that we have right off, so I don't want to convert them. I'm being a little bit lazy here. So let's use this relationship in order to compute what the VRMS is. So we're going to rearrange this to get VRMS. Oh, you can't see this color. I can't see it myself. VRMS squared is equal to 3 times n times r times t divided by n, or let's use this little n times the molecular weight. Here's our new formula. And so let's solve that on the next page. So our equation is we have VRMS squared equals 3nRT over n times the molecular weight. We can see that the n's cancel. I'll use a different color just to illustrate that. N's cancel. And so this is equal to 3 times 8.3 joules per mole times 473 Kelvin, joules per mole Kelvin, divided by the molecular weight. Now we have iodine. What we're told in the problem is that iodine is 127 AMU, atomic mass units. Oh, that's cryptic. That is the 127 grams per mole. All right. So VRMS, let's see, 127 grams per mole. Let's see where we're at with these units after we begin kind of crunching this through, and I'm going to need to erase this guy here. Whoa! I just realized something as I was writing that down. Iodine is 127 grams per mole, but iodine gas is twice that. It's diatomic. It's 254 grams per mole. So I'm going to need to erase this and make that reflect 254 grams per mole. Let's see where we're at with the units now in this math here. I'm going to cross out moles, Kelvin, and so let me just keep the numbers together. So whoa, that's a bad color. VRMS squared equals 3, oops, that's not a 3, 3 times 8.3 times 473 divided by 254. I'm keeping the numbers together because Pete doesn't have you use calculators, times joules over grams. Now a joule, we're going to need to convert that obviously. A joule is a, let's see, how do I always go like this. I go work equals force times distance, and I know force is a Newton, and I know work is a joule. So I know a joule is a Newton meter. Now I need to break this down. I always do this. I say, okay, well, force, I know force equals mass times acceleration. So that's a kilogram. Acceleration is meters per second squared. So I know a Newton is a kilogram meter per second squared. Now notice I have a mixture here. If I go ahead and cancel what units I can, I have joules here, newtons here, and grams and kilograms here. So I need to convert this grams to a kilogram. So I know that there are 1,000 grams in a kilogram. Let's see how we're doing the units here. So we still have VRMS squared is equal to this number, whatever this is. I'm just going to call it A. A times, what do we have here? Grams, canceled with grams, kilograms canceled with kilograms. We're left with meters times meters over second squared. So we're getting close here. So it's equal to meters squared per second squared. Now when I take the square root of that, V RMS is equal to the square root of A, and the units are meters per second. So I'm all set there. Now all I need to do is do this math. What is the value of A? So I'm going to kind of estimate here. It's going to be quick and dirty. 3 times 83 is roughly 20, a little more than 24. So we have on the top a little more than 24 over 254 times 473. So 0.3 times 3 is 9, 24. This is like 25. See, what I did, 3 times 8 is 24. 3 times 0.3 is 0.9. So 24 plus 0.9, that's roughly 25. So I'm going to call this 1. I'm going to call this 10. 25 over 254 is 1/10 of 473. So got 1/10 of 473. It's roughly equal to 47.3. I'm going to need to take the square root of that. That's the value of A. This 47.3 is the value of A. I take the square root of A. Meters per second. Square root of 47 is, I'm going to call it 7. 7 meters per second. This is the velocity.